let's proceed with example 2. You have integrate from 0 to half of a square root 1 plus 4x squared dx. So now we need to realize that this is trigonometric substitution because you have the form of square roots of constant squared plus variable squared dx. Okay, so let's adjust this a little bit. You have third of 1 squared plus 2x squared. Okay, so now let's see this here. When you have a square root of 1 squared plus 2x squared, therefore the constant a is equal to 1 and your variable x is actually 2x. So let's open up. If you have this type of form, therefore with plus here, this is x equal to a tangent theta. So let's write here, your x now is 2x equal to a, which is 1 tangent theta. Therefore, now we have 2x equal to tangent theta. So now let's find x. Let's bring 2 here to become a 1 over 2. So x is equal to 1 over 2 tangent theta. And let's differentiate this. Therefore, dx is equal to half. Differentiate tangent theta is secant squared theta d theta. So now we have finished differentiating your x here. Now, since you have a limit, we have to do something different. We need to change the limit. Why? Because originally we don't have any limit. So whenever you have your answer in terms of theta, you need to exchange back by using right angle triangle in order to find the answer in terms of x. However, since we have limits here, we don't have to do that. When we want to change everything is in terms of theta right now, we just change the limits and just keep our answer as it is and then just fill in the new limit. However, let's adjust a little bit our equation. We have tangent theta is equal to x just now. So your theta should be inverse tangent to x. So now this is needed in order to change the limit. So originally your x is equal to 0. So when x is equal to 0, what is your theta? So just substitute this here. So this is just inverse tangent 2 times 0. So inverse tangent of 0, this is just 0 in terms of radian. For another one, when your x is equal to half, your theta is equal to inverse tangent 2 times x. So theta is equal to inverse tangent 2 times half. So just cancel out. So now inverse tangent 1. Therefore, inverse tangent 1 is just equal to pi over 4. So now we have finished changing the limit. So our new limit now is from 0 until pi over 4. Now let's change everything in terms of theta. And you have a square root of 1 plus tangent squared theta. And your dx now is equal to 1 over 2 secant squared d theta. So now half is a constant. Let's take it out. And 1 plus tangent squared theta, you have this value here in trigonometric identities. This is equal to secant squared theta. So let's write here square root of secant squared theta, and this is left with secant squared theta d theta. So now let's cancel out this square root and square here. So when you multiply this, this is just 1 over 2. Integrate from 0 until pi over secant cube theta d theta. So we have learned this from the previous chapter. If you want to integrate secant cube theta, you need to use IBP. So let's do this. Integrate secant cube theta d theta is just integrate secant theta secant squared theta d theta. Let's split this. Alright, and then let's do our IBP. Let u as secant theta, let dv as secant squared theta d theta. Let's differentiate this. du over the theta is just secant theta tangent theta. du is secant theta tangent theta d theta. And from here, dv is secant squared d theta. Therefore, v is just tangent theta. Now we are ready to open up the IBP. So this is just uv minus integrate v du. Okay, so just write it here. And let's solve. The first one is already settled. And we just focus on the second term here. So tangent and tangent is tangent squared. While secant theta d theta, just write it back. So now let's open up again. Tangent squared theta is just secant squared theta minus 1 times secant theta d theta. And let's expand this again. This is secant theta tangent theta. So now let's expand this. This is just minus integrate secant cube theta, and minus minus is plus plus with secant theta d theta. So now let's take the question again. Integrate secant cube theta d theta. This is equal to this. And I hope you can see that this same term. So this is special case of IBP. Along the way, you'll have the question back. So let's solve this one. Just bring this to your left hand side. So we have 2. Integrate secant cube theta d theta. And for your right hand side, you're left with secant theta tangent theta plus integrate secant theta d theta. And finally, you can solve this too. Just bring it here. It's become 1 over 2. And in bracket here, this is just secant theta tangent theta plus integrate this. Just use your formula list. This is ln secant theta plus tangent theta. And let's write plus c. So from our question just now, let's revisit our original question. So let's rewrite as half. And for this one, let's just copy your answer here. And don't forget to write plus c. Now let's open up, expand everything. So you have 1 over 4 secant theta tangent theta plus 1 over 4 ln secant theta plus tangent theta plus c. So here I have solved it without the limit. So now let's focus to fill in the limits here. So your limit is from 0 until pi over 4. So let's do this. For the first part, just rewrite here from 0 until pi over 4. And for the second part, again, this is from 0 until pi over 4. So let's open up. Put in your pi over 4 first. And then minus, put in your 0. Plus, for the second part, put in your pi over 4 and put in your 0. So this is it. So let's open up the value here. We know that secant pi over 4, this is 2 over set 2. Tangent pi over 4, this is just 1. Secant 0, this is 1. Tangent 0 is 0. So the whole thing here will become 0. And for the second one, secant is just 2 over set 2. Tangent pi over 4 is 1. While secant 0 is 1. Tangent 0 is equal to 0. Okay, so let's fill in all of the answer inside. And let's just simplify this. And finally, you will have your answer here. Set 2 over 4 plus 1 over 4 ln set 2 plus 1. Therefore, this is your final answer.